You want to just take a picture of the worksheet and send it to my email. It might be easier than verbalizing all of it.
All right, maybe. Let me see. Today is the 29th. Uh,
Depends.
oh,
You can verbalize.
I don't really have any homework. I only have to do some stuff with like, my teacher only assigned me to work on like Khan Academy and SAT prep, but I mean, we can do
Well,
something
what would you
else.
like to work on? Let's work on whatever it is you want to work on.
Oh, factoring. I need help. I need to like figure that out a lot better.
Let me help. Let's start with a couple. When you are factoring, and it doesn't really matter whether you're factoring an expression or if I set that equal to 0 and make it an equation. If I make
All
it
right.
an equation, you're going to solve it by factoring. That's the only way to solve it. Okay? Let's talk about the steps that you take. Now, I call all of these first level quadratics. And I call
All
them
right.
first level because the coefficient of x squared is 1. These are easy to factor. They start getting harder when you get second level. But let's make sure that you can factor everything that is first level.
All
And
right.
there are 3 to 4 very simple steps that you follow every single time. Okay? I'll go through this one with you. The first step is you split up the x squared. After you split them up, make sure that when you multiply them back together again, you got what you started with.
All right.
Second step, and this is where most people go wrong. Second step is to determine what both signs are. By signs, I mean, am I going to have a plus or a minus after this x?
A plus.
They both have to be plus. First of all, what you're doing when you're factoring is the reverse of FOIL, right? You were taught FOIL?
Yeah.
Okay. When you, in other words, you're right, they're both plus, but whatever number I write right there and there, those two numbers have to multiply to plus 10. And the only way you can get a plus is if both signs are negative or both signs are positive. If one is positive and the other is negative, then that has to be a negative.
All right.
In this case, they're both positive. Now, the third step, really quite simple. I want factors of 10 that add because of that plus. If that was a minus, it would be factors of 10 that subtract. But because it's a plus, I want factors of 10 that add to the number 7. Not plus 7, just the number 7. In other words, whatever the absolute value, that coefficient of the x term is. Well, what factors of 10 add to 7?
5 and 2.
Yeah. So it's x plus 5 times x minus 2 equals 0. Now how do I solve this equation?
Um, you. I'm not really sure. I don't.
Algebra says is that if you have one quantity multiplying another quantity and you get 0, well then one of these has to be 0 by definition. You cannot find two numbers that multiply together to give you 0. They don't exist. When you get 0 from multiplication, one of them has to be 0. So the next step is we set both of them equal to 0 and we solve. That gives you x equal minus 5, and the other one, x plus 2 equals 0, giving you x equal minus 2. So those are your two solutions for x.
All right.
Okay, let's do a little harder one. Not much harder, still first level. This time it's going to be x squared minus 3x minus 10. Still first level, still going to have 4 very easy steps that we're going to go through. All of these first levels can be done in either 3 or 4 steps. Okay? First step, what is it?
We have to split the x up, so put x on each side of the equation. And then
Second step.
we have to find out what.
No, both signs. That's the second step. That's the one everybody wants to skip over. Don't skip over it. It'll make it far easier if you do this in 3 or 4 exact steps every single time. So what are both signs?
The second step, hang on. I'm trying to see.
Signs have to be the opposite, don't they? The only way I can produce a negative 10, remember that is the last step of FOIL, is where you multiply this number with its sign times that number with its sign.
Yeah.
Well, if the signs were the same, this would be a plus 10. So the moment I see a negative sign in front of the constant, I know it's plus minus. Now, it could also be minus plus, but that's the same. In other words, in this case, with these first level quadratics, minus plus is the same as plus minus. Now, step 3. Step 3 before said factors of 10 that add to the coefficient in the middle. Well, this is going to be factors of 10 that subtract to 3.
All right, so that would be 5 and 2 again.
Okay. Now, those are the factors, but we still have a fourth step now. We have to figure out whether the 5 goes with the plus sign or the minus sign. And here's the way what the fourth step is. You take the larger of your two factors and put it with the sign of the middle term. The sign of the middle term is negative, therefore the 5 goes there, and the 2 goes there.
All right.
Now, let's talk about one other thing. Once you have factored it, you want to check it. Make sure you did it right. Okay?
All right.
We don't actually have to FOIL it. We could FOIL the whole thing out, and I get minus 5x plus 2x minus 10. Notice these two middle terms always combine. The end terms do not, but the middle terms do. So that is what we started with. So we factored it correctly. But my point is you don't actually have to do the entire FOIL. You don't really need to check that term or that term. The way we did the factoring, those aren't in doubt. We know we got those correct. We split the x's up, and then we split factors of 10 up. So I know that the first and the last term are correct. What is maybe in a little bit of doubt is that middle term. And you get the middle term by the inside and the outside. That's the O and the I of FOIL. Well, that's 2x. That's minus 5x. Add them together, you get minus 3x. That's what we're looking at. We did it correctly.
All right.
Now, if all of that's equal to 0, what's my answer?
Then your x has to be 0 too?
Not x. This quantity has to be 0.
Oh, all right. So the 2 has to be 0.
Both of them you set to 0. X plus 2 equals 0. Solve that, you get an answer of minus 2. That's one answer. The other one sets to 0. Solve that, you get an answer of 5. So our two answers are x equal minus 2 and x equal 5.
Okay. That makes sense.
Okay. Now, that's as hard as first degree quadratics get.
All right. Well, they're like,
Let's talk about second degree quadratics, because those were hard. In other words, at this point, you should be able to do every simple quadratic, no matter. Here, let me just test you. Let me give you a simple one. Let me think for a minute. And instead of solving an equation, we're just going to factor this expression. Still going to factor it into two linear terms.
all right.
What are the steps?
Splitting the x up into both sides of the
Tell me what goes in each of these. In other words, say x there and x there.
All right, yeah, x.
So sometimes saying splitting the x doesn't work. If I've got 4x squared, I got lots of ways I can split that. I can split it as 4x and x, or I can split it as 2x and 2x. So just saying splitting the x isn't enough. It is in first levels, but it's not in when you get into second level quadratics. You have to be a little more specific. Okay?
All right.
Step?
The next step is figuring out the signs.
What are they?
Right? If one has to be a minus and one has to be a positive.
Okay. Third step?
We have to
verbalize it out loud. Because notice that if you can verbalize this third step, it's easier to remember.
I'm trying to think on what to do. I'm sorry.
Factors of 20.
Okay, factors of 20.
That do
that subtract.
Correct. To what?
To x.
Not
I don't know. Not x.
Coefficient. The absolute value of the coefficient. What's the coefficient of x?
2. So squared.
Mm-hmm. Oh. It's 1. There's a 1 right there.
Oh, all right, all right.
In other words, when you see x, there's a 1 right here too, and there's a 1 right there. In other words, there's always a 1 implied, just like there's a 1 exponent also. But you don't have to write it if it's 1 usually. So I need factors of 20 that subtract to the number 1. What factors might that be?
5 and 4.
Okay, and finally, what's the fourth step? The only reason there's a fourth step is because we have a negative sign in front of the 20. If that was a positive sign, there's only 3 steps. But
so does that mean
figure out which side to put the 5 and which side to put the 4, you need that fourth step.
Oh, all right, all right.
The largest factor goes with the sign of which term?
The sign with the negative.
The middle term.
The middle term.
In other words, that negative 20 isn't the reason we put the 5 with the negative sign. It's the negative 1. The sign of the middle term is negative. Therefore, the larger of the two factors goes there. And now, if I'm going to check it, again, I don't have to FOIL the whole thing back together again. I just need to check, make sure I got the correct middle term. Well, that's minus 5x. That's plus 4x. I call this my double smiley face method. That gives us minus x in the middle. That is our middle term. Therefore, we've done it correctly. Okay?
All right.
All right. That should be a primer on first degree quadratics. Now let's take a look at a second degree quadratic. I'm going to have to, here, let me think for a second what is going to do this. put a minus 12 there. And let me think for a second. I think that works. Okay. Notice this is not first degree because it's not a 1 in front of the x squared. It's a 2. Any number other than 1 makes it harder, makes it second degree. Okay?
Okay.
Furthermore, I cannot factor out a 2. In other words, if this thing was 6x, then I would just factor out that 2 and make it a first level quadratic, right?
Yeah.
And there are problems, you will get problems like that, where that's a 6, and then you could just factor out a 2, and you'd be left with x squared minus 3x minus 6. But in this case, because it's a 5, we can't do that. So we have to factor it as a second level quadratic. First two steps are still the same. What was the first step?
Splitting, or no, I can't split it, but I have to move the x's to both sides of the equation.
Well, no. You're going to factor it like a quadratic. You're going to factor this just the same way we factored the first level ones. You're going to leave everything on one side of the equation, 0 on the other, and factor this quadratic. That means separating it into two linear terms. So when I split the x's up, what do I get?
X minus or plus. It's
First
plus.
step, no, first step only. Split the x's up.
All right. So then the other x goes on.
It's not an x, it's a 2x. And after you split them up, make sure you multiply them back together again to get that term. Because we have to produce 2x squared as a first term in the final quadratic. Okay.
All right.
So we don't really have any choice of how to split the two x's up. In other words, it can only be x and 2x. It doesn't really matter if I put the 2x first and the second x second. It's going to be the same thing. Second step. Still the same. Second step.
The second step is finding out the function that's gonna go to it. So like minus or plus.
Second step's real easy. Both signs.
Yeah. All right.
What are they?
So if it's equals to 0, then is it?
Forget that. Let's just make it an expression. I'm factoring this expression.
Then it's minus on both sides.
Nope. That would give you a plus 12.
Yeah.
So they have to be opposite signs. By definition, when you're looking at a minus sign in front of the number, a constant, then the signs have to be opposite. One has to be plus, one has to be minus. The difference here is that plus minus is not the same as minus plus. So I have to allow for both. I'm going to have to test both because they're going to give different answers. Now, there's no more rules. In other words, I cannot say factors of 12 that subtract to the number 5. Those kind of rules don't work anymore on these second level quadratics. It's a trial and error process. Give me all factors of 12, starting with that.
2 and 6, 3 and 4.
The way I do this is I cut that in half and double that. If I can do it again, I do it again. Now I'm done. I got all factors of 12. Now, which two should I start with? This is a trial and error process at this point. And that's the way they teach it to you. Even if they taught you the California method or the Diamond method, it's a trial and error process. Okay? First level quadratics are not. First level quadratics, you got those 3 or 4 rules and that's it. You can solve every one pretty quickly with just those 3 or 4 rules, and there's no trial and error involved. Okay? But here there is. So we need to pick one of them to start with. And what I tell everybody is always pick the two that are closest together. Merely because that's the way they design problems in the state of Colorado, is they make it so that the factors are the two factors closest together. Not 100% of the time, but 90% of the problems you're going to get, your factors are going to be the factors closest together. They're not going to be 12 and 1. They're not going to be 6 and 2. They're going to be 3 and 4.
All right.
Okay. Now, let me think for a moment. If I try the 4 there, no, I don't want to do, hold on. I want to try the 3 there and the 4 there. That's what I'm going to start with, just randomly. Not because I see anything, but I just have to start trying these things. There's 4 possibilities here. I can have 3 minus 4. I can have minus 3 plus 4. Or I can put the 4 on the left side and have plus 4 minus 3 or minus 4 plus 3. So I got 4 possibilities here. I got to find one of them that produces this minus 5x in the middle. Now, for these second degree quadratics, this is an integral part of solving it, is the double smiley face. In other words, we got to figure out how to produce a minus 5x. Well, 3 times 2, that's plus 6x. Minus 4 times x, that's minus 4x. That's minus 2x. Well, that isn't right. So now, the fact that my number was not right, and the sign, I don't care about the sign, but the number wasn't right. If I move this 3 down to the negative sign and the 4 down to the positive sign, I'm going to produce the exact same number, only the different sign. In other words, I'm going to produce plus 2x. So that can't be right either. So the 3 here and the 4 on the right doesn't work, no matter how I do it. So let's switch it. Let's make it 4 there and 3 here. Remember, this is trial and error. Now, what does that produce as a middle term?
6x again.
No, multiply that by that. What's that?
Oh, 8x. My bad.
And then minus 3x. So what does that give you?
That's negative 5x.
No, actually it isn't.
Or 5x. It isn't?
Positive 5x.
Okay. Positive 5x.
Positive 8x plus negative 3x is a positive 5x. Well, that's not the right answer either, but I got the right number. Which means is all I have to do to get the right answer is to move that 4 down to the minus sign and move the 3 down to the plus sign. Now what's my middle term?
That now was negative.
Well, I got minus 8x from the inside. I got plus 3x from the outside. There you go. Minus 5.
Yeah, negative.
In other words, once I find the middle term, I'm done. My answer is x minus 4 times 2x plus 3. That's the way that quadratic factors. And it doesn't matter whether I'm factoring an expression or I'm solving an equation. In other words, if I'm going to make all of that equal to 0, then all of this equals 0. And now I can set that equal to 0 and solve it. I can set that equal to 0 and solve it. I solved my equation.
All right.
Okay. So there's factoring in a nutshell. At least quadratic factoring. There's other kinds of factoring. There's greatest common factor, there's difference of perfect squares, and if you can't factor it the way we've been factoring all of these, then you have to use the quadratic formula. So there's a bunch of things you have to consider when you look at a factoring problem. But the most important thing is really to either determine whether it's a first degree or a second degree. First degrees are easy. Second degrees you can see are a little harder. I had to go through 4 combinations before I found the right one.
Yeah.
And if 4 and 3 hadn't worked, I'd have had to go try 6 and 2 4 different ways. And if that doesn't work, I got to try 12 and 1. So there's a lot of trial and error. But like I said, if you stick with the factors that are closest together, that usually is the right answer. That will usually produce the middle term you're looking for. But it's all about producing that middle term when you have these higher degrees of quadratics. All right, Britt, I got to go. I got a noon. For some reason, Sunday is crazy. I got more appointments today than I've had any day this week. So, yeah, it's weird. Wow.
Thank you.
You're
Appreciate
welcome. Talk to you next time.
Yep. Adios.
Bye-bye.